Okay, welcome back. So this is part 3 of my everything you need to know about going into taking the class of organic chemistry so you don't get totally frustrated and throw your laptop out the window. Class, video series. This is part 3. Part 1 was the introduction of the carbon skeleton, when they draw molecules like this and you're like, what are they talking about? That's part 1. So if that confuses you, go back to part 1 and just speed through that real quick. Part 2 is just kind of a side note about wedges and dashes. And then now we are on part 3 where we're talking about the side groups, also called substituents, and then also their nomenclature, which means how to name them. Okay, so we're familiar with this, right, from my first video. If this carbon backbone, carbon skeleton, is just all single bonds, then it's called an alkane. And when you're naming it, it gets the suffix. The last part of the name is going to be that A-N-E, that ane. And you just count how many carbons there are. And remember, there's a carbon at the ends and at each corner. So that's 1, 2, 3, 4, 5, 6. So look down here, 6. The prefix meaning 6 is hex. So we put this hex as a prefix, and the ane, it was the suffix. So this is hexane. Then, now you remember expanding this, we have the alkane, the 1, 2, 3, 4, 5, 6. So this is hexane because it's all single bonds. So we end it with that suffix ane, ane. But if you have a double bond, which is right here, we have to count the carbons. Okay, so let's count the carbons. So we got 1, 2, 3, 4, 5, 6, 7. So that's 7 carbons. And as we see, 7, hept is the prefix for 7. So we know we're going to have hept. And this is a double bond. This has a double bond right here. And even if the rest of the molecules are all single bonds, if it has this double bond here in the main carbon skeleton, then we're going to end this in ene, E-N-E, instead of A-N-E. So we're going to go heptene. But then we also have to tell where the double bond is located in this molecule. So we want to number these carbons to give the double bond the lowest number possible. So if we go 1, 2, 3, 4, that means we would have the double bond starting on the 4. Or if we go from this side, 1, 2, 3, that means we would have the double bond starting at the 3. So you want to pick the lowest number possible. And so we know there are 7 carbons in this chain, which is why we put hept. But the double bond, which is the ene, starts on carbon number 3. And so we want to put 3-heptene, or you can also write it as hept-3-ene. And you always put hyphens on either side of the number to separate the number from the letters. That's just a standard pattern. Okay, so now going down here to the triple bond ends in an ine, Y-N-E, right? So this has a triple bond to it, so we know it's going to end in Y-N-E. And let's see how many carbons it has. 1, 2, 3, 4, 5, 6, 7, 8. And if that confused you, go back to part 1 of the video. I go through triple bonds. So this is 8 carbons in it. So 8 is oct, like an octopus has 8 legs. But now we have to indicate where the triple bond is in the octine, making it the ine triple bond ending, Y-N-E. So we want to give this triple bond the lowest number possible. So if we number it from left to right, 1, 2, 3, 4, 5, then this triple bond starts on 5. But if we number it this way, 1, 2, 3, then the triple bond starts on 3. So that's the lowest number, and that's what we want to give it. So we can say 3 octine, or we can say oct 3 ine. Okay, so everybody remember that? Got it? Good. So now, what about if you have this carbon chain, right, but then you have something sticking off of it? Well, that is called a substituent. It's anything coming off of this carbon skeleton, which is kind of like, this is like the backbone of the molecule. Other things can be coming off, like this substituent here. We could have something coming off of here like this. This could have something else on it. This could have like an OH at the end or something or whatever. Just something coming off of the main carbon backbone. Those are all called substituents. So how do we deal with that? Well, you want to do the exact same thing we've been doing. First, you just ignore the substituent. You just look at what's called the parent chain. And the parent chain is the longest possible carbon chain you can find in the molecule. Like this would be the longest carbon chain, hydrocarbon chain that you see in this molecule, right? And so it's got 1, 2, 3, 4, 5, 6 carbons in the parent chain. The prefix for 6 carbons in the parent chain, in the carbon chain, is hex. And as you can see, these are all single bonds, right? So we know the suffix is going to be ane. So we know this is some type of hexane. It just depends on where this side chain, this substituent, is located on the carbon chain, and also what shape it's in and how many carbons that substituent has itself will classify this hexane further, and it'll specify what kind of hexane this is. And we'll get to that in a minute. First, I just want to practice with you just real quick, being able to spot the parent chains in the molecule, because sometimes it gets a little tricky. So I want to take you through some trick questions. So let's look at this next one. We have 1, 2, 3, 4, 5 carbons in this chain before it splits, and there's 1 carbon over here and 1 carbon over here. So in this case, no matter which way you go, if you go this way or if you go this way, you're still only going to get 1 more carbon. So in that case, you can pick whichever one you want. It doesn't matter. So let's say if we want to pick this one down here, there's a carbon right here. So 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5, 6. So this is also a 6 carbon chain. So here's the parent chain. I'm outlining in red. So this would be the parent chain. And I just picked one of these two randomly because they both only have one carbon at the end. So it doesn't matter which one you pick. Okay, so we know it's got 6 carbons in the chain. We know that 6 gives the prefix of hex. We can see that this is all single bonds. So we know it's going to end in ane. So this is another hexane. And we'll get back to what we're going to do with these substituents in a minute. Here's another molecule right here. And so we have one carbon down here. And then here is where the split takes place, right? So right here is where it splits either here or here or here, right? So we want to find the longest section in this carbon chain, which in this case, this is symmetrical. It's either the left side or the right side. It doesn't matter because the left side has 1, 2 carbons in it before it gets to the split, where the split takes place. And the other side, this has 1, 2 carbons in it on the other side. So these are symmetrical. So you can just choose one. So I'll just choose that one. And then should we go and continue with this, this line that we were talking about right here that's symmetrical with this other line? Or should we go down here to this hanger offer and include that in the parent chain? Well, this down here only has 1 carbon in it, while this up here has 1, 2 carbons in it after the split, the carbon where everything splits. So we want to choose the one with the most carbons because we want the longest possible continuous carbon chain in the molecule, and that is going to be the parent chain. So now we want to number those carbons. How many carbons are in that chain? 1, 2, 3, 4, 5. So that's 5 carbons in that chain, in the parent chain. And so 5 is pent for the prefix. So we know this is going to be a pent something. And then these are all single bonds, right? So we know it's going to end in ane. So we know there's this substituent here that we haven't dealt with yet that we'll come back to. But so far, we know that this is going to be some kind of a pentane, right? Okay, now let's look at this second one on the right, okay? We have this little stretch right here. Here's where the carbon where everything splits, right? And this little stretch right here only has 1 carbon at the end of it. This stretch right here has 2 carbons, 1, 2. And this stretch right here has 2 carbons, 1, 2. So we don't want to use this stretch right here as counting in the parent chain because we want for the parent chain the longest possible chain of carbons. This only has 1 from where the split is. So that's not going to work. We have 1, 2 over here, and we have 1, 2 over here. Okay, so there's 2 carbons on either side of the carbon where everything splits. So it's symmetrical, right? Because there's 2 carbons on either side. So we're going to take that identified row of consecutive carbons, and we're going to number them 1, 2, 3, 4, 5. And you always want to, just like I was showing you with the doubles and triple bonds, when you number those, you want to make sure you give double and triple bonds the lowest number possible. So just like that, when you have substituents sticking out of the carbon chain, when you number that parent chain, you want to give that substituent, wherever that split point is, you want to give that the lowest number possible. So since there's 1, 2 carbons on this side, and so the third carbon is the split carbon if you number it from right to left. But if you go from left to right, there's 1, 2 carbons on the left side. So that makes the exact same number. That makes carbon number 3 where everything splits. So this is even either way. You can number it either way, left to right, right to left. It doesn't matter because the 3 is still 3 where the carbon splits off into a substituent. You just want to make sure that that carbon where it splits off into a substituent gets the lowest number, however you number it. So it doesn't matter. We know there's 5 carbons in this parent chain, right? 5 is pent, so we know that's going to be a pent something, and it's all single bonds, so we know it's going to end in ane. So pentane, and we will be back to add the substituent into the name in a little bit. As I said, I just want to get you used to looking at tricky looking molecules and still being able to identify the parent chain. Okay, so here we go. Here's some good stuff right here. We have a carbon chain. It looks like 1, 2, 3, 4, 5 carbons on this side. And we have, because here's the carbon where everything splits off into substituents, right? So on the other side of that, the carbon where everything splits, we have 1, 2, 3, 4 carbons. So this is 5 carbons over here. This is 4 carbons over here. So now let's look down at this part where it looks like it might be the substituent and not part of the parent chain, but sometimes you can't tell. You really have to count the carbons. So let's look. Okay, so we have 1, 2, 3 carbons is the longest part in this chain that splits off right here. So only 3 when we have 4 and we have 5 up here. So we're going to keep this top sawtooth jagged edge shape as the parent chain, and we're going to count the total number of carbons in the parent chain. We have 4 over here, so 1, 2, 3, 4, and this would be 5 is where the split takes place. 6, 7, 8, 9, 10. Now, if we were to number that going from right to left, just to make sure that that 5 is the lowest number we can go, just to check. 1, 2, 3, 4, 5, 6. So yeah, if we went from right to left, this would end up being the carbon 6, not the carbon 5. So we want the lowest number, so we're going to stick with that 5 where everything splits off. But the total number of carbons is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 carbons in the parent chain. Down here is DEC, so that's going to start with DEC. And then this is all single bonds, right? So we know it's going to end in A and E. And we will come back to how to add the rest of the name for the substituent in a second. Okay, this next one over here, we have 1, 2, 3, 4 carbons before you get to the split. And on the other side, we have 1, 2, 3, 4, 5 carbons before you get to the split. And down here, we have 1, 2 carbons on the other side of the split. So we know that's not going to be part of the parent chain. So we know this top part is, though. So we're going to give this the carbon where the carbon splits the lowest number. So this will be 5, 6, 7, 8, 9, 10. So again, 10, that's DEC as in December. So DEC is that prefix. And this is all single bonds, so it's going to end in ane. So we know it's a decane. and we'll come back to adding that substituent's name in a minute. So down here, we have 1, 2, 3, 4 carbons before the split. Over here, we have 1, 2, 3, 4, 5 carbons before the split. So we know this is the lower number one. And let's just check it. Eyeballing it, you can tell this is shorter, but let's just check just to make a good habit. 1, 2, 3 carbons only on this one hanging down here. So this must be the substituent. So we are going to number this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, 10. It's a dec, and it's all single bonds, so it's another decane. But do you see how all these decanes are looking different? I mean, each decane has a different substituent hanging off of it. This one has this. This has this little fork-looking thing hanging off of it. This one down here looks like a crane getting ready to scoop something up, right? So it's really these side groups, because all these carbon chains all kind of look alike, right? So it's really these side groups that define exactly what molecule this is going to be. Because so far, all we know is that it's a decane, even though they all split at the carbon 5 in the parent chain, but they're all different. They're all different shapes, the substituents coming off. And that is what makes the difference between each molecule, really, is those side groups. All right, so let's go to this next one, this last one over here. We've been seeing this the entire page. We can see that this is the same thing as this, except this substituent is different. Do you see how it has an extra like elbow or knee in there as opposed to this one? But the carbon parent chain is the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this again is a decane. And so we will return to this in a minute. Okay, so one more series of trick questions here for the parent chain, because really this is where you get tripped up. You want to make sure you get this down and you won't get so tripped up later. Okay, so here are some parent chains, and look at this one. This one has a double bond to it, right? So if it has a double bond, it's going to end in E and E, right? Okay, so now when we number this, we want to number it giving double and triple bonds and substituents the lowest numbers possible, right? This could be the parent chain right here, but this has a substituent here, and it has a substituent here sticking off. So what do we prioritize? Which do we give the lowest numbers to? Well, your priority should be, first, you want to make sure you give the lowest possible numbers to your double and triple bonds. Then after you've done that, then you give the next lowest numbers to your substituents. So see, we didn't have to worry about that in the examples I was showing you before, because we didn't have double bonds competing with the substituents. We were just doing single bond carbon skeleton and a substituent. But now this is more, molecules have more than one thing on them. So we want to make sure we prioritize the double and triple bonds first. Then after that, give the substituents the next lowest numbers. But we do want to make sure the double bonds get the lowest numbers. So here's the first carbon right here. Here's 1. So this double bond starts on 2. And then here's 3, 4, 5. And then we could go 6, 7 or 6, 7, because this is the same amount of carbons as this on either side of where the chain splits. We got 1, 2 carbons down here, 1, 2 carbons up here. So it doesn't matter. You can pick either one. You're not wrong. Doesn't matter. What does matter is we need to know that this has 7 carbons in the parent chain. So 7 is going to be hept. So we know this is going to be some kind of heptene, because of the double bond. And we know that the double bond starts on 2, right? So we know to write it hept to ene to show the carbon number 2 is where that double bond starts, which makes the ene. So hept to ene. And then we're going to come back in a minute to finish naming this with that substituent. Let's go on to this one for right now, though. So we have another double bond right here. And you always want to give priority to giving the double and triple bonds the lowest number when you're numbering the parent chain, not the substituents. Substituents come second. So we want to make sure that this carbon number 1, 2, 3, is the priority, because this gives that double bond the lowest starting carbon number. And then we have 4, 5, 6, 7, 8, 9. Because see, if you would have gone down this way after the 5, and you would have gone 6, 7, 8, you would have only gotten 8 carbons out of that chain, right? So you want to go where the most carbons are in a row. So that's going to be 9. So 9, as you can see down here in the chart, 9 is known, and this has a double bond, so it's going to be nonene. And the double bond starts at the 3rd carbon, so it's going to be non-3ene. And then we have a bunch more labeling to do with the substituents, but we'll get right back to that. Let's do this bottom one right here. Now we've got, we've got 1, 2, 3 before the split on this side, and we only have 1, 2 before the split up there. So we know this is going to be part of the parent chain, the more number of carbons in the chain. So next is going to be 4, carbon number 4, and then carbon number 5, carbon number 6, 7, 8, 9. So this is a 9 carbon chain, which is non, and it's all single bonds, so that's nonane. And then we will have to return in a minute to finish up with these substituents. So as I had said before, these are called substituents, and that's the side groups that come off of the carbon chain and stick out. Now, when you have another carbon chain attached to the parent carbon chain, like you'll see down here, so here's the parent carbon chain. I mean, we can just obviously tell by eyeballing it that this is the longest one available, right? So there's the parent chain. So coming off of the parent chain is this extra piece, right? So this extra piece is the substituent. And we want to look at how many carbons this extra piece has. So this is 1 carbon, 2 carbons. Now, don't get confused and count this attachment carbon in with the substituent. Because see, if you did that, you would get 3 carbons, right? You don't want to count what's on the actual parent chain, because we've already counted that carbon on the parent chain. So you can't count that again. You only want to count the carbons on the actual substituent. And then this carbon is just bonded to the chain right there. So this only has 2 carbons in the substituent. We know the parent chain is the one going across it horizontally. And let's see, on the right, we got 1, 2, 3 carbons before you get to the split. On the left, you got 1, 2, 3, 4 carbons before you get to the split. So we're going to want to go with whatever gives us the lowest number for the substituent. So this is going to give the number 4 to the attachment carbon where the substituent comes off, right? Because if we were to number them the other way, 1, 2, 3, 4, 5, it would give you 5 as the carbon for where the substituent branches off, not 4. So you want the lowest number. So 4 is where the substituent branches off. Now we know there's 8 in this chain, and 8 is oct, like an octopus has 8 legs. So we're going to go oct, and it's all single bonds. So we know it's going to end in ane. And we will return to finish naming those substituents. So let's go back to what we've been doing so far this video, and let's talk about how to put the substituents in there. Okay, so here we're back to where we started from, and we know this is a hexane because the parent chain, the longest carbon chain, is 6 carbons in a row, right? So it's hexane. So now we have to look at the substituent. So what we do is we look at how many carbons the substituent has. Now, as I said before, don't get tripped up and think that it's 2 carbons linked to each other is the substituent, because that's not right. What's going on is that this carbon up here is already the attaching point, and it's part of the parent chain. So we already counted this as part of the parent chain. You can't count it again. So this substituent only actually has 1 carbon, and then it's just bound to the attachment carbon out of the carbon skeleton. So 1 carbon, we use the exact same prefixes as we were using before. This has 1 carbon, so its prefix is going to be meth. So meth. But since now this isn't methane, because methane would mean it's the parent chain, the parent carbon chain, and it's only single bonds. Well, this meth carbon definitely only has a single bond to the parent chain, but it's not part of the parent chain. So remember, the all single bonds in the parent chain is an alkane, and you end it with ane. If there's a double bond, it's an alkene, and you end it with ene. If it's triple bond, it's an alkyne, and you end it with ine. Well, when you attach a substituent to a carbon chain, you have to what? You have to take off one of the hydrogens that was on there, right? Because carbon always has to have 4 things bonded to it, or 4 bonds. So if there's nothing else attached to it, it's going to be all hydrogens. But so once you bring a substituent into it and you attach it to one of the carbons, you can't have that attachment there and those 2 hydrogens and the bond to the carbon before it and the bond to the carbon after it, because that would be 5 bonds. So you just take away a hydrogen. A hydrogen just goes away, and instead of that hydrogen, you have the substituent. And now we've established the substituent's prefix is meth because it only has 1 carbon in this particular one. And instead of ending it in ane, instead of ending it in ene, instead of ending it in ine, you end a substituent, a carbon chain with a hydrogen removed so it can attach to something else, is an alkyl. So this is going to be a methyl, because it's the Y and the L from that alkyl and used as a suffix. It's going to be a methyl hexane. Now, we still need to indicate where on that hexane is this methyl group coming out of, because that makes a difference on what kind of hexane you have. So as we had numbered these before, 1, 2, 3, we give the lowest number to where the substituent comes out, which is number 3. So this is going to be a 3-methyl hexane. So when you're writing that, you want to separate the numbers from the letters with a hyphen. So you want to go 3 hyphen, and then the methyl. The methyl goes in front because that's the substituent, and that lets us know that the methyl group attaches at the 3rd carbon on the main parent chain. So we have the 3-methyl, and then we just add the rest of the word hexane to this new prefix. So 3-methyl hexane is going to be the name of this molecule right here. So now let's try this one at the bottom. Now we already see that it has 6 carbons on the parent chain, and that means hex. It's a hexane, it's all single bonds. So where's the substituent? Well, here's the substituent right here, and it has 1 carbon, because the carbon it's attached to is the attachment carbon, which is part of the parent chain. So you already counted that in the parent chain, so you don't count that in the substituent. So it's just 1 carbon. So let's look over again. 1 carbon says meth, and since it's a substituent, we put -il at the end of it, methyl hexane, and it is on the number 2 carbon. So that is 2-methyl, because the methyl group sticks out from the 2nd carbon in the parent chain. And then you just add the name for the parent chain onto the end of this with no hyphens or anything. So 2-methyl hexane. All right, so now we're back to the decanes that we were working on a minute ago. And so let's go to this first one up here. So we know it's a decane because it has 10 carbons in the parent chain, but the split, let's look at where it splits off into the substituent. Well, the split is at the 5, carbon 5, right? Okay, so we know it's going to have 5 hyphen something. So we're not going to put just 5 decane. Why not? Because we're going to look at decane and think 10 carbons in a row. But then we're going to see the 5 and be like, well, what happens at 5? What about 5? We don't know. So what we need to do is describe what happens at carbon number 5 in the decane parent chain. So at carbon number 5, we have how many carbons attached to this attachment carbon number 5. Well, it comes down here and it attaches. So that's the connecting carbon right there. And on one side, there's 1 carbon, and on the other side, there's 2 more carbons. So if we number this from end to end, 1 carbon, 2 carbons, 3 carbons, we have a total of 4 carbons altogether attached to the carbon number 5 in the main skeleton in the parent chain. So carbon number 5 is going to get a 1, 2, 3, 4 atom substituent attached to it. So let's look up 4. So 4 is bute. So we're going to go bute, and we're going to put the YL at the end of it because it's the substituent. And then we're just going to go on ahead and write the rest of the word decane. So 5-butyl decane. Now let's look at this one next to it on the right. We've already established that this has 10 carbons in the parent chain, and so we already know it's a decane, and it's all single bonds. So let's look, and here's the attachment. Carbon number 5 is the attachment. So we're going to put 5 down because carbon number 5 is the attachment atom where the substituent's coming off at, right? So we have 1, 2, 3, 4 carbons coming off of that carbon 5. So those 4 carbons, we're going to look down here, and that's bute again. So we know we're going to have butyl decane. And since it splits off at carbon number 5, then that's going to start with a 5-butyl decane, because the butyl group, the 4 carbons, which is a butyl group, attaches at carbon number 5, which is why the 5. So now let's look down in the middle one. Okay, so we already know this is a decane because 10 means dec and ane means all single bonds. So we know here's the connecting carbon. We've already established this. So we count how many carbons is on the substituent. You don't count the connecting carbon. So 1, 2, 3. So 3 means propyl, and this is attached at the 5, right? So we're going to have 5-propyl decane. Now let's try this one down here. So this is going to be another decane, and I'll just put up here 10 and 1. Okay. Now we have a substituent sticking off right here. All right. Now on the carbon parent chain, we have 1, 2, 3, 4, 5. So on the 5th carbon, you are going to have a structure with 1, 2, 3 carbons in it. Now let's look up what number 3 is the prefix for number 3, and that's prop. So we're going to go 5-propyl. You got to put that ill on there to make sure everybody knows you're talking about a substituent, something that's sticking off of the backbone, not part of it. So 5-propyl decane. Now, if you look to your right, this other one here just has one little difference to it. Instead of the 5-propyl decane, it's still 5, right? It's still 5. And let's see the substituent. The substituent has 1, 2, 3, 4 carbons to it. So that makes it a butyl group, and it's attached to the 5, which I already put 5 down there. And the parent chain itself lasts for 10 carbons in a row. So that's decane. So we're just going to tack that on there to the end of butyl. So now this is going to be 5-butyl decane. So now what if you have both a double or a triple bond and a substituent, like in this one over here on the left? Well, so as I said before, but I don't know if I was direct enough or was clear enough. When you're competing a substituent against like a double or triple bond, it's doubles and triples bonds win. They get the lowest carbon number in the chain. So in this case, we can give the double bond starting on 2, and then 3, 4, and then 5 is the connection point where the substituent group sticks off of. So since this is a double bond on here, and we know it because, and we have the ene ending, meaning double, it has a double bond to it, and the double bond starts on 2, so we have that already. So we're going to go hept. Hept is from the 7 total carbons in the skeleton. Hept-2-ene, right? But now we have this other substituent we need to take care of. So it's on the attachment carbon number 5. So we're going to have something start with a 5 and a hyphen. And then let's count the carbons on the substituent. We have 1 and then 2 here at the end. So that's only 2 carbons on the substituent. And 2 carbons is F, ETHF. And of course, we put a YL at the end of that, so it's ethyl. And then we just continue on with the name, 5-ethyl hept-2-ene. Okay? Okay, now we know we're supposed to prioritize the double and triple bonds first to give them the lowest number when we're numbering these parent chains, which we've done. We have carbon number 3 right here starts the double bond. The double bond's going to start on 3, which is what we have in the name so far, the non-3-ene, because it's a double bond. But then let's look at all these other substituents coming off of it. Now, at 4, the double bond ends, so we don't need to mark that. So carbon number 5 has a substituent on it, and how many carbons is in the substituent? We have 1 carbon, 2 carbons, 3 carbons, 4 carbons. All right, so that's 4. So if you look down at the chart here, 4 means bute. Okay, the next carbon is a carbon number 6, and that has a substituent on it. Now, how many carbons is in this substituent? Just 1, right? Don't get it mixed up and count this one too, because this is part of the parent group. So we already counted that. We don't count that again. So it's just this 1. 1 carbon is in the substituent. So 1 is meth. So we know we're going to have a methyl also, and this is branches off of the parent carbon chain at carbon number 6. So we're going to have a 6-methyl. And then let's go to the next carbon in the parent chain. We have carbon number 7, and we have a substituent on here. Now, how many carbons is in this substituent? Just 1, right? So that's another methyl. So we have a methyl up here, and we have a methyl right here at carbon number 7. So we're going to have a 7-methyl and then nothing on the 8 and nothing on the 9. Okay, so we're good. We've listed them all. We know the basic, the parent chain is going to be this non-3-ene, right? But then we have a butyl at carbon number 5 and 2 methyls, one at number 6, one at number 7. So what do we do? How do we name something like this when it has all these different details that we have to include? Well, we keep what I was teaching at the beginning, which is the parent chain, non-3-ene. So that's going to be at the end, because that's really the root. That's what all this stuff is branching off of. That's going to be at the end. Before that, we're going to have these different substituents listed. You might think that you would list them in numerical order, like 5, 6, 7. But no, that's not how they want you to do it. What you do is you alphabetize them. So there is a B for butyl, and there's 2 methyls. Obviously, B comes first. So at first, we're going to have 5 butyl, and then we got to go to the next number for the next substituents. But these are both the same substituents. So we're not going to go 6 methyl, 7 methyl, because that's too much writing and that takes too much time. So what we're going to do is after the 5 butyl, and you always separate numbers from any letters with hyphens in either direction. So 5 hyphen butyl, and then hyphen, because we're getting ready to write another number. We have 2 methyls, one at 6, one at 7. So what you do is you just list all the numbers, all the carbon numbers in the parent chain where a methyl is located. So in this case, it's 6, then comma, 7. So you know there's 2 different methyls, one at 6 and one at 7. So you do another hyphen. Now we need to write the methyl to let everybody know that 6 and 7 has to do with the methyl, right? But there's 2 methyls. So if you remember from part 1 of the video, when we had 2 of something, we preceded it with the prefix di, meaning 2. So you have di, meaning 2, tri, meaning 3, tetra, meaning 4, and so on. So we're going to write after this 6, 7 hyphen dimethyl, just to letting you know the di is there. It's kind of redundant, but it's there to let you know, yes, you're not crazy. I did say 6 and 7, so there's 2 methyls. So in all, we're going to have a 5 butyl, because B comes alphabetically first, 5 butyl, and then 6, 7 hyphen dimethyl, known hyphen 3 hyphen ene. Woo! So yes, it is. Yes, that is the technical name for this chemical. Now don't worry, I'm trying to intentionally give you some complex ones so you feel very comfortable with whatever is thrown your way. Okay, so now we have this one down here. And as I'm doing this down here, I realized that I made a mistake the first time around when we were identifying this parent strand and numbering it. Do you see the mistake? It's not an involved mistake, it's just a silly one. I skipped the connecting carbon of the parent strand when I was numbering everything. So I went 1, 2, 3, and then I skipped this, and then I went up to 4. So we ended up getting 9 carbons in the parent strand for nonane, but really 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually, this is a decane. So if you caught that earlier, then points. Now, we have this decane, so we know the decane is going to go at the end of the name, and that's going to go at the end to kind of anchor everything down. So what we need to do is we need to look at what kind of substituents we have coming off of all of this stuff. So let's see, the first one, at number 4, we have 1 carbon, 2 carbons in a substituent. Because remember, this is just the bond between the connecting carbon and the substituent carbon. So this is just 1 carbon, 2 carbons. So if you look on the chart, 2 carbons is F. So this is going to be ethyl, and that's at connecting carbon number 4. So we're going to go 4 ethyl. And then the next carbon up, carbon number 5, has another substituent to it. And this has 1, 2, 3 carbons to it. And 3 carbons on the chart is prop. So it's propyl. And this is at connecting carbon number 5 on the parent chain. Now let's go on to the next carbon on the parent chain, carbon number 6. And it has this substituent. So how many carbons is this? 1, 2, 3, 4. 4 carbons. And that's butyl. And this is carbon number 6 on the parent chain, butyl. And then on the parent chain, carbon number 7, there's another substituent. And this has 1, 2, 3, 4 carbons on that. So again, 4 is but. So this is carbon number 7 on the parent chain, another butyl. And that's it. Nothing on the 8, 9, or 10. So now remember, we know that we're going to have the decane at the very end of the name. So what we need to do is we need to figure out how we're going to arrange these substituents to put at the beginning before decane. So you alphabetize them. So we have, here's B's. So that's going to be the first one. And there's 2 of them, right? So we're going to go 6, 7 for both of them, one for each, hyphen, and then dibutyl to let everybody know it's 2 different butyl groups, 1 at 6 and 1 at 7, and then another hyphen, and then what's alphabetically next? So ethyl before propyl, right? So we're going to go 4 hyphen ethyl, and then another hyphen, and the 5 hyphen propyl. And then at the end of that propyl, we're just going to run into the rest of the name, propyl decane. No hyphens because there's no numbers to separate. So just propyl decane. So finally, the technical name for this molecule down at the bottom is going to be 6, 7 hyphen dibutyl, because there's 2 of them, 1 at 6 and 1 at 7, hyphen 4 hyphen ethyl, and hyphen 5 hyphen propyl, and then just keep on going with the ending of the name, decane. So 6,7 hyphen dibutyl hyphen 4 hyphen ethyl hyphen 5 hyphen propyl decane. Woo! I didn't know if I was going to be able to fit that on the screen.